This lesson is about the volumes of pyramids and cones. So our objective is to find the volume of a pyramid and the volume of a cone. The volume of a pyramid is related to the volume of a prism with the same base and height. So we knew that the volume of a prism is going to be the area of the base times its height. Well, the volume of a pyramid is going to be 1/3 of the product of the area of its base and height of the pyramid. And remember, the height of the pyramid is defined as the distance from the vertex of the pyramid perpendicular to the base. That's the height. And then the area of the base is whatever polygon the base is. You need to find the area of it. Now the next statement says that because of Calaveri's principle, the volume formula is true for all pyramids, including oblique. O-B-L-I-Q-U-E. Oblique pyramids. Oblique pyramids means it's leaning. So if it's leaning, how you measure the height, you still measure it from the vertex, and you still have to go perpendicular. It just may not be on the base of the pyramid, but it's on the surface, the same plane as the base of the pyramid. So it's the same formula, whether it's a right pyramid, upright, or whether it's oblique and leaning. The volume of a cone is related to the volume of a cylinder with the same base and the height. So once again, let's look at the volume of a cone. It's going to be very similar to the relationship between the prism and the pyramid. So where the volume of a pyramid was 1/3 of the volume of a prism with the same base and height, the volume of a cone is going to be 1/3 of the product of the area of its base and the height of a cone. Okay, so it's similar to a cylinder, only it's 1/3 of the corresponding cylinder. So here, of course, we still have 1/3 of the base times the height, but the base is a circle, so it's pi times the radius squared times the height of the cone. So this formula also applies to the volume of all cones, including oblique cones. So even if it's a cone that's leaning, the height, once again, is going to be measured out to the side in that same plane that the circular base is in of the cone. So let's look at some problems. In problem 1, we're finding the volume of a pyramid. This is the Great Pyramid of Giza. Is the largest of the original 7 wonders of the world. The pyramid originally had a dimension shown over to the side, so it wants you to find the approximate volume of the Great Pyramid. So these are some pretty large numbers. The height of the pyramid is 485 feet, and the base is a square that is 755.5 feet. So the volume is going to be 1/3 of the area of the base times the height. So it's 1/3. The area of the base, since it's a square, is going to be the side squared. So it's 755.5 squared is the area of the base. And then times the height, which is 485. So if you plug that in, you're going to get a large number. It's going to be approximately equal to 92,276,140, and that is in feet cubed for the volume. Problem 2, you have another pyramid, and it's asking for the volume in cubic yards of a square pyramid. So once again, you get a square pyramid with the base edges 18 yards and a slant height. Slant height is 15 yards. So you're going to have to, and we don't need the slant height for this. We need the height of the actual pyramid. So the actual height. So we need this perpendicular height that's down inside this. So if we draw this, since it's a square pyramid, if you can draw a small right triangle inside, okay, you got a right triangle, and so we have the slant height is 15, which is the hypotenuse of the right triangle, and this edge of the square base is 18, so the bottom of the right triangle is half of that, is 9. So we have to use the Pythagorean theorem to find the height. So the height is one of the legs of the right triangle. So height squared plus the 9 squared has got to equal 15 squared. So that's height squared plus 81 is 225. And then subtract the 81 from the 225 and take the square root of both sides. So you get 144 when you subtract 81 from 225. Take the square root of both sides. So your height of this pyramid is 12. So now you got to use that to plug into your volume formula, because volume is still 1/3 the area of the base times the height. So we have 1/3 the area of the base, since it's a square with a side of 18, is 18 squared. And then the height, which we just found, is 12. So plug that in your calculator and you will get 1,296 yards cubed. In problem 3, we're finding the volume of a cone. This is about how many cubic centimeters of water does the paper drinking cup hold. It gives you a diameter of 8 and a slant height of 11. So once again, we've got to find the height, the actual height of that cone. The radius is going to be half the diameter, so that's 4. And your slant height, which is the hypotenuse of the right triangle, is 11. So the height squared, using the Pythagorean theorem, height squared plus 4 squared is equal to 11 squared. So let's solve that one. Height squared plus 16 is 121. Subtract the 16 from both sides. You get 105, and you got to take the square root of both sides to solve for h. So you get the square root of 105. And we'll just leave it as the square root of 105 to put it into the formula, because the volume is 1/3 the area of the base times the height. 1/3 the area of the base is a circle, so it's pi times the radius squared times the height. So put in, for your radius, it's 4. So we got 4 squared. And then the height, put in the square root of 105. Plug that into your calculator, and you're going to get that it's approximately equal to 172 centimeters cubed. In the last problem, we're finding the volume of an oblique cone. So this is one where the vertex of the cone is not directly above the center of the base. It's shifted or leaning over to one side. So we have to give our answers in terms of pi and also rounded to the nearest cubic inch. So our volume formula is the same. it's 1/3 the area of the base times the height, which is 1/3 pi r squared, since the base is a circle, times the height. It gives you everything you need in the diagram. The radius of this, that gives you the diameter is 16, so that means the radius is going to be 8, half of the diameter, and the height is the perpendicular distance from the vertex to that base, and that's given to you as 15. So we're going to multiply this together and leave it in terms of pi first. So multiply the 1/3 times the 8 squared times the 15, and you'll get 320 pi inches cubed. And to round it to the nearest cubic inch, if you multiply 320 times pi, you'll get 1005 inches cubed.